Knight tour in chess. While we are still thinking about translation, another example may be given, which illustrates one very important use of the translation, namely, to put our problem into a form where the answer can be seen at a glance. Such a translation does not change the essential patterns of the problem. From various abstract mathematical viewpoints, one might say that it did nothing at all. But for us as human beings, it is most valuable since it changes the unfamiliar into the familiar. Wow! Drawing the graph of the algebraic function illustrates my meaning. A graph can be taken in by the eye at a glance. Here we are translating from algebra to geometry. Very often we translate in the opposite direction from the geometry to algebra. Several examples will be found in this book. And we may also translate from geometry to geometry from the unfamiliar type of the problem to a familiar one. Yes. Consider the puzzle of the knight tour. A knight is placed in the center of the square board of the 25 squares. The knight is to move in such a way that it visits each square once and once only. I find it very difficult in thinking about this puzzle to see clearly in my mind whether or not the knight is getting into difficulties when he was made, say, a dozen moves. I cannot tell by looking at the squares still unvisited whether they will join together in a single chain of the knight's move. Can we somehow restate the problem so that we shall be able to see more easily what we are doing? From the point of view of the knight, the square 2 and 13 are the neighbors. Yes. He can jump from 13 to 2 in a single move, but from his point of view, 12 and 13 are not neighbors. He cannot pass from one to another in a single move. So, if we are only concerned with the problem of the knight tour, we can forget the actual shape of the chessboard. If we want to bring out the things which are important for the task in hand, we must draw a diagram of the 25 squares in such a way that 2 is close to 13 while 12 is not so close. In fact, the knight needs 3 moves to pass from 13 to 12. The resulting diagram is shown in the figure 7. If a knight can pass from one square to another in a single move, the corresponding numbers are joined by a straight line. The place where the lines cross have no significance. In the diagram drawn on the paper, it seems impossible to avoid such an accidental crossing. They could be avoided in a 3-dimensional model with wires joining the points. These wires could be bent so as to avoid each other. The drawing of such a diagram is not quite as simple as it looks. Some care is needed if one is to avoid a tangled network of lines. The main principle used was respect for symmetry. 13 had to be in the center and the other arranged around it so as to preserve the symmetry of the chessboard. It is now very easy to choose a path for the knight. He can, for example, go from 13 to 10, then go right around the inner circle. 19, 12, 22, 11, 2, 9, 20, 23, 16, 7, 4, 15, 25, 17, 6, 3. Pass to the outer circle and go around this. 12, 21, 18, 25, 14, 5, 8, 1. We need not go into the theory of the knight tours. The example The example is chosen not for the importance of the subject, but rather to illustrate how the suitable way of visualizing essential features of their problem can simplify the task of finding solution. Wow, really?